In this video, we're going to work example problems where we find volumes of solids of revolution using integration. However, for each problem, we're going to analyze the problem and then decide whether we'll use the disc washer method or the cylindrical shell method. Okay, so this first problem, we want to find the volume of the solid that's created by rotating the area contained between these two curves. So here's minus x squared plus 6x minus 8, and here's y is equal to 0. Rotating this area about the y-axis. Okay, so should we use the disc washer method or the cylindrical shell method? Well, to decide which method is easier, one thing you can consider is which method results in easier limits of integration. So if we treat x as the independent variable, then it looks like we've got pretty simple limits of integration. We're going from x is equal to 2 to x is equal to 4. But if we're treating y as the independent variable, then we'd have to figure out what is this local maximum here, which isn't that big of a deal, but still, it looks like the limits of integration, treating x as the independent variable, are simpler. But probably the main point to consider is, so the heights of the rectangle in each method are both determined by evaluating the function in terms of the independent variable. And so you want to see which method is easier to evaluate the function at the independent variable. So if we're treating x as the independent variable, then here's a typical rectangle. In this case, we could see then we'll be using the cylindrical shell method, because when you revolve this rectangle about the y-axis, you get the cylindrical shell. But to get the height, we need to evaluate this function as a function of x. So we're getting it's y as a function of x. And yeah, this looks pretty simple. You just plug in x and you get the height y. Whereas if we did it this way, to where here's a height of a rectangle. Well, for one, so we plug in y, we'd have to subtract this value minus this value. So yeah, so when we solve for x as a function of y, we're going to have two values for each given y. You can see, right? This value and this value. You have to subtract those. So this is more complicated. So definitely, we want to go ahead and we want to treat x as the independent variable here, which means that we're going to be using the cylindrical shell method. Now, one thing to notice is that about the analysis that was just done, I never really mentioned anything about discs and washers or cylindrical shells. I was just more of talking about which axis are we going to treat as the independent variable, right? That's all I was analyzing. I didn't care if it made no difference if the x-axis here, we determined that treating the x-axis as the independent variable was the simpler way. If that resulted in the disc washer method, then okay. Like I didn't say, okay, the x-axis is the simpler independent variable to use, but that results in the cylindrical shell method, so we have to reconsider something. It made no difference whenever the independent variable x was the simpler way, it made no difference what that happened to be associated with, if it was the cylindrical shell or disc washer method. So we were strictly looking, just saying which axis are we going to treat as the independent variable, which results in which makes it simpler to determine the rectangle. That's what the analysis was about. Just something to notice. So, all right, so we're going to use the cylindrical shell method. And so the volume of a cylindrical shell, here's that average radius r, the midpoint between the inner radius and the outer radius. So you go 2 pi of that r value and get the circumference. Then you multiply that times h, and then you multiply by the thickness. Okay, and we can see that the thickness is going to be the delta x, the delta independent variable. So, okay, let's verify that the limits of integration are in fact 2 and 4. Visually it looks like that's the case, but we want to verify this mathematically. So, okay, I'm going to solve for when minus x squared plus 6x minus 8 is equal to 0 for x. X is equal to 2 or x is equal to 4. Yeah. Okay, so the volume is going to be, we're going from 2 to 4. And so what's the volume of each of these differential elements, right? You imagine rotating this about the y-axis to get a shell. So it's 2 pi. What is r here? R is this distance. So it's just the x coordinate. 2 pi x. Okay, now what's the height? The x, it's this, x evaluated here. So minus x squared plus 6x minus 8. Okay, and then the t is, or it's dx. dx. There we go. So now we just need to evaluate this definite integral. So minus x cubed plus 6x squared minus 8x. Okay. So we've got minus 1/4 x to the 4th plus, would it be 2x cubed? So you take this derivative, that's 6x squared, yep. Minus 4x squared, yeah. Okay, evaluated from 2 to 4. Okay, so plugging in 4. So 4 to the 4th divided by 4 is 4 cubed, which is 64. So, okay. 4 cubed is 64. 64 times 2 is 128. And then 4 cubed is 64. All right, minus, okay. So you've got 2 to the 4th divided by 2 squared is 2 squared, so minus 4. 2 to the 4th is 16. 2 squared times 2 squared is 2 to the 4th, so minus 16. Okay, so this is 2 pi minus 64 minus 64 is minus 128, plus 128 is 0. Okay, so minus 4. So 2 pi times positive 4 is 8 pi. Okay, so here we want to rotate the area contained between y squared minus x squared is equal to 1, which is this curve, and y is equal to 2. So we want to rotate this area about the x-axis. Okay, so do we use the x-axis or the y-axis as the independent variable? And so if we used the y-axis as the independent variable, that looks like it would be the cylindrical shell method. Yeah, it would be. Why is that? Because you think about rotating this rectangle about the y-axis, you get a cylindrical shell. Okay, and if we use the x-axis as the independent variable, that's the disc washer method. So, all right, as far as solving for x or y explicitly, it looks like it's going to be just as difficult both ways. We're going to have like a plus or minus, but like we'll have like y is equal to plus or minus square root of x squared plus, so it'll be the same. It's the same either way. But to me, this looks like, to get this height, it looks kind of tricky, like you're subtracting the if we solved for x as a function of y, we'd get like plus or minus something, and we'd have to consider both of those values. But if we solved for y as a function of x, then we'd get plus or minus, but we could ignore the one of the values because it would be referring to this down here. And then, okay, what about the limits of integration? Here, it looks like the limits of integration are a little more complicated for the x value, but so what? That's not that big of a deal. So to me, let's use the disk washer method. Let's have x be the independent variable. So the limits of integration, what we're going to do is, when does 1 plus x squared, so we're going to do, all right, so y squared is equal to 1 plus x squared. So y is equal to plus or minus square root of 1 plus x squared. And so, we can just, we'll ignore what they're talking about. The plus or minus is, so like if you plug in x is equal to this value, it's the result is this and this. But we're going to ignore the negative. We're going to ignore this. So we just want to solve for when does square root of 1 plus x squared equal to 2? Okay. So when does square root of 1 plus x squared equal 2? At plus or minus root 3. Okay, so this is minus root 3, this is positive root 3. So b is equal to root 3, a is equal to minus root 3. I mean, that's a little more complicated than integrating from 1 to 2, but it's definitely, to me, this is not that big of a deal. So, okay. So we've got this is the disk washer method. This is the washer method because we're going to have a hole in the middle. And so a washer has volume, and the way we use it for this formula is, so you have R outer, R inner, and then you've got the thickness, and so the volume is pi R outer squared minus R inner squared, and then times the thickness. Right? This is that classic right cylinder, the right cylinder method. Each position x, you're getting the cross section that cuts through the solid, and then just the delta x is the thickness. That's like the definition of a right cylinder. Okay. So the volume of this solid of revolution, we're integrating from minus root 3 to root 3. Okay. Pi times R outer squared is what? So we're going from x is equal to here to x is equal to here. So in general, we're at this x value here. We're at x. What is R outer? It's just 2. Right? Think about the washer. Think about revolving this and how you get a washer. What's the outer radius of that washer? It's 2. So 2 squared is what? 4. Now, what about the inner radius? Well, this is where the function comes in. Okay? The function is square root of 1 plus x squared, positive square root of 1 plus x squared. So when you square that, what do you get? 1 plus x squared. Okay, now the thickness, dx, there we go. Bring out the pi. So we've got 4 minus 1 is 3 minus x squared dx. So what we have is 3x minus 1/3 x cubed evaluated from minus root 3 to root 3. So pi, and then we've got 3 root 3 minus, so 3 root 3 cubed is what? So 3 to the 1/3, or 3 to the 1/2 cubed is 3 to the 3/2. 3 to the 3/2 divided by 3 to the 1st is 3 to the 1/2, so root 3. Okay, minus root 3, we've got minus 3 root 3. All right, minus root 3 cubed is minus 3 to the 3/2 divided by 3 to the 1st. So this is going to end up being plus root 3. Okay, so we've got pi 3 root 3 minus root 3 plus 3 root 3 minus root 3. 3 root 3 minus root 3 is 2 root 3, plus 3 root 3 is 5 root 3, minus root 3 is 4 root 3. 4 pi root 3. Okay, we want to rotate x squared plus y minus 1 squared is equal to 1 about the y-axis. And so you can see this is an equation of a circle that's shifted from the origin just up 1 unit in the y direction. So yeah, there you go, with radius 1. And so if we're going to rotate this about the y-axis, then you're just going to get a sphere. So we could kind of cheat here and just go get the formula for the volume of a sphere and plug in radius equal to 1. So the volume of a sphere is 4/3 pi r cubed. So when r is equal to 1, you just have 4/3 pi. So that should be our final answer, but we're trying to practice the integration here. So we're going to sum this with cylindrical shells or with discs or washers. To me, it's going to be discs or washers. I'm not sure how we do this with cylindrical shells. Oh, okay, yeah. What we do with cylindrical shells is we would treat x as the independent variable and then do this. And then rotate about the y-axis. And I guess we would just integrate from minus 1 to 0. And that's pretty confusing. So to me, we're going to do discs washers like this. Or it's going to be discs. It's going to be discs, and we'll integrate from 0 to 2 with y as the independent variable. That just by first glance, that's got to be easier. So, okay, we're going to be integrating along the y-axis from a is equal to 0 to b is equal to 2. Y is equal to 0 to y is equal to 2. And so, okay, it's just pi r squared. It's a disk, right? Disk of radius r. So the volume is pi r squared thickness. And the thickness is going to be dy. So what we need is, so we're going from 0 to 2. So at each point, we need just the r. That's all we need. So what's the r? The r is this length. And so we need to solve for x as a function of y. And so if we take this equation, we say x squared is equal to 1 minus y minus 1 squared. Take the square root of both sides, and we've got x is equal to plus or minus okay, now what does this mean? What this means is that, so if you plugged in y is equal to 1, what happens? You get plus or minus the answer. You get if x is plus or minus 1. So that's correct, right? When y is equal to 1, you've got two answers. X is equal to 1 and x is equal to minus 1. So how do we use this? Well, if you think about it, what we can do is we can just take the positive value and multiply by 2, right? That's the whole idea. If we just ignored the minus and we said we plugged in y is equal to 1, we get 1, right? But when we multiply by 2, we get that length that we're looking for. Well, actually, I take it back. We don't need the full length. We just need the radius. So we don't need to multiply by 2. We can just use the positive value. So the function we're going to use is this. That's the radius function. And then we're going to square it to get in this. When you square it, you'll get rid of that square root, so it'll make it easier to evaluate. So let's do it. The volume is, you go from 0 to 2, then pi, what is r squared? Here's r. So let me, 1 minus, just remove the root, pi r squared. Now the thickness, dy. There we go. So we can bring the pi out, and we've got 1 minus y squared minus 2y plus 1 dy. Okay, we've got 1 minus y squared plus 2y minus 1 dy. So 1 minus 1 is 0, so it's really 2y minus y squared dy. Okay. So we've got, this is y squared, we integrate it, minus 1/3 y cubed, evaluated from 0 to 2. So we plug in 0, this just goes to 0, so we just need to evaluate this at 2. 2 squared is 4. 2 cubed is 8. Okay. 3 over 3 divided by 4, or 3 over 3 times 4 is 12 over 3. 12 minus 8 is 4, so it's 4/3 pi. Okay, last problem. We want to revolve the area contained within these two curves. And so here is x minus y is equal to 1, the line. And then here's the x is equal to y minus 1 squared. We want to revolve this about x is equal to minus 1. Okay, so the question is, the question is not do we use discs, washers, or cylindrical shells. The question is, do we use the x or the y axis as the independent variable? The x or y is the independent variable. That's the question. And when we determine that answer, then whatever that happens to be, the disc or washer or the cylindrical shell method, we'll just use that. So, all right. If we think about just glancing at this, it looks like having y as the independent variable is going to be the easiest. How would we even use, I can't even see how we would use x, right? Because you can think, okay, we'll be integrating from 3 to, well, first of all, yeah, we can see it's easy. It's going to be 3. We're integrating from y is equal to 0 to 3. And then if we draw a element here, so this will be the washer method. We'll be revolving this around x is equal to 1, right? Oh, wait, I forgot. Let's come back. Yeah, see? 4/3 pi, 4/3 pi. Pretty cool. We got the volume of the sphere. All right, so, okay, yeah, we'd have to, the height would be this function minus this function. Yeah, so we're going to be using y as the independent variable. Let's see, if we wanted to do the cylindrical shell, it would be, we would have to, so we'd have to do 2 separate integrations. We would do one in this region from x is equal to 0 to 1, and then we do another integration from 1 to 4. And we absolutely could do that, no problem, and we'd get the right answer. But it's just 2 separate integrals, and it's just, just seems a little more complicated. But we could absolutely do that, no problem. Like, you have to have 2 separate integrals because the functions within the integrals would be different. From here to here, you would have the height of the rectangles would be based on just this curve. For each x, you'd have 2 y's, and you would have to, like, I guess you'd have the higher y minus the lower y, yeah. And so now you'd integrate from 0 to 1 with that height, but then the rectangle height when you're going from 1 to 4 would be this function minus this function. So you have to do 2 separate integrations. If we use the disk washer method, or if we use y as the independent variable, then, and you can see it's the cylindrical shell, because if you revolve this around the x is equal to minus 1, you get the cylindrical shell. But if we use this would be the washer method in this case, you can see it's going to be a washer, then it's just one integration. So, but I just want to stress, you could absolutely do the other way if you wanted to. All right, so we're going from 0 to 3, it looks like. Y is equal to 0 to y is equal to 3, but let's verify this mathematically. And to do that, so we're going to be having x as a function of y. So here we'll have x is equal to 1 plus y, right? We want to, for this blue line, we want to plug in a y and get the x. So if we set these 2 equations equal to each other, y minus 1 squared is equal to 1 plus y, and we want to solve for y. Y is equal to 0 or y is equal to 3. Yeah, there you go. See, that's where they meet. Y is equal to 0, y is equal to 3. So we're going to be going from a is equal to 0 to b is equal to 3. Okay, and the volume of the washer is pi r outer squared minus r inner squared times the thickness. Okay, and so what is let's see, so I guess we can go ahead and set up, the thickness is going to be delta y. We can go ahead and set up the integral. So, okay, we're going from 0 to 3, pi, okay, what is r outer? So, okay, we're walking along from 0 to 3, y is equal to 0, y is equal to 3. So we're at these y values as we walk. And so when we're here, we're at this y value here. And so how do we get the outer radius? This is the outer radius. We need to plug this y value into this. So it's 1 plus y, but we square it, r outer squared. So let me do y plus 1 squared. Okay. Now, what is the inner radius? It's just you plug in y to get this distance to the red curve. That's y minus 1 squared, but then you square that, so y minus 1 to the 4th. And then dy. Now, this is kind of unfortunate to have this big of a, I don't want to have to expand this. So, but this is the right integral. We just need to evaluate this integral. So let's see what happens if we can make u equal to y minus 1. Okay, then in that case, du is equal to dy. Okay, and then, so let's see, this could work. So when y is equal to 0, u is equal to minus 1. When y is equal to 3, u is equal to 2. We can bring this pi out. Okay, now what happens here is you have, what is y equal to? Y is equal to u plus 1, right? So we've got u plus 1 plus 1. So you've got u plus 2 squared. Yeah, this should work. Okay, minus, and then u to the 4th, which is that's the big thing that we try to do. Then we have to expand this, and then dy. Yeah, there you go. Okay, that's a good problem. I might make a short on that. That, this is how you can. This is a good example of how you can use substitution to simplify an integral. Okay, so minus 1 to 2, then we've got u squared plus 2u plus 2u plus 4 minus u to the 4th. Okay, now let's do the integral. So 1/3 u cubed plus 2u squared plus 4u minus 1/5 u to the 5th. Going from minus 1 to 2. Okay, so we've got 2 cubed is 8, so 8/3. 2 squared times 2, so 2 cubed is 8. Plus 4 times 2 is 8. Minus 2 to the 5th is 32. Okay. Minus, and put in minus 1, so you got minus 1/3 plus 2 minus 4 plus 1/5. So we've got what? 16 plus 8/3 minus 32/5 minus, so 1/5 minus 2 minus 1/3. So 16 plus 8/3 minus 32/5, 184 over 15 minus, okay, so 1/5 minus 2 minus 1/3 minus 32 over 15. So this is going to be plus 32 over 15. So 184 plus 32 divided by 15 is 72 over 5. So 72 pi over 5. The textbook answer key says it's 117 pi over 5. So let's see. I'm pretty confident this integral is set up correct. So it's just an error in the calculation of the integral, the evaluation of it. So u is equal to y minus 1, du is equal to dy, and then you plug in y is equal to u plus 1. U plus 1 plus 1 is u plus 2 squared minus u to the 4th, okay? when y is equal to 0, u is equal to minus 1. When y is equal to 3, u is equal to 2. U squared plus 2u plus 2u is 4u plus 4 minus u to the fourth. Okay. 1/3 u cubed, yeah, plus 2u squared, that gives 4u. Then this derivative gives 4. Then this derivative gives u to the fourth. Okay. You plug in 2, you get 2 cubed is 8, 8/3. Plug in 2, you get 2, another 8. Then 4 times 2 is 8. Then 32 or 5. That's right. Okay. Minus, and then plug in minus 1. So minus 1/3 plus 2 minus 4, and then it would be plus 1/5. Okay. Pi, and then you've got 16 plus 8/3 minus 32 over 5 minus, and then 1/5 minus 2 minus 1/3. Okay, then 16 plus 8/3 minus 32 over 5 is 184/15. 1/5 minus 2 minus 1/3 is minus 32/15. So you add those. Okay, so I must have set up the integral wrong. Oh, I see what happened. Okay. I absolutely set up the integral completely wrong. Why? Because I revolved it around x is equal to 0, not x is equal to minus 1. So if we're here, the outer radius is this value, but then you got to add this distance. You have to add minus 1 to it. So I'm going crazy. All right. So the integral is from 0 to 3 pi. What is r outer? It's, you plug in the y value you're at, so 1 plus y, but then you add 1 to that, right? It's this distance plus 1, because we're revolving this about this axis. So it's 2 plus y, so, or y plus 2 squared, okay? Minus the inner radius squared. What's the inner radius? It's this distance here. That's going to be, so y minus 1 squared, that value, you plug in y, you get, so y minus 1 squared, and then plus 1 squared. Let me change these brackets so you can see this. dy. Okay, so I still say we do that substitution. U is equal to y minus 1. Du is equal to dy. So we've got, this is pi when y is equal to 0, u is equal to minus 1. When y is equal to 3, u is equal to 2. Y is equal to u plus 1. So u plus 1 plus 2, you got u plus 3 squared minus, and then you've got u squared plus 1 squared, and then du. Okay. So you've got u squared plus 3u plus 3u, okay, minus u to the fourth plus 2u squared plus 1. Okay. So u squared plus 6u plus 9 minus u to the fourth minus 2u squared plus 1 du. Okay. So minus u to the fourth minus u squared, so okay, plus 6u plus 10. Okay. So now doing the integration. Okay, so we've got 2 to the fifth is 32, so minus 32 divided by 5 minus 8 thirds plus 24 plus 20 minus, then you've got 1/5 plus 1/3 plus 3 minus 10. So minus 32 fifths minus 8 thirds plus 24 plus 20. 524 over 15. Minus 1/5 plus 1/3 plus 3 minus 10. Minus 97 over 15. So this is plus 97 over 15. Okay, 524 plus 97 divided by 15 is 207 over 5, which is still not the right freaking answer. Okay, according to the answer key, this is the right integral. So the error is coming in the evaluation of the integral. All right, u is equal to y minus 1, du is equal to dy, so that you get y is equal to u plus 1. U plus 1 plus 2 is u plus 3, minus, then you've got u squared plus 1 squared, okay? U squared plus 6u plus 9 minus u to the fourth plus 2u squared plus 1. Yeah. Okay, now this was so u squared plus 6u plus 9 minus u to the fourth minus 2u squared minus 1. So minus u to the fourth, and then u squared minus 2u squared is minus u squared, and then 6u, and then plus 9 minus 1 is 8. There you go. So this is an 8. All right, 8 times 2 is 16. And then this would be minus 8. Okay. So if we come back, this is 16. 464 over 15. Okay. And then 67 over 15. All right, 67 plus 464 divided by 15 is 177 over 5. It still is not what the textbook is saying. The textbook's saying 117, so I guess I'm just getting tired on this last example, so we're getting closer. Let's do this. Let's plug in this. Let's just make 100% sure that this is the right integral. So y plus 2 squared, okay, then y minus 1 squared plus 1 squared, okay, this minus this, and then all that times pi. Okay, store this as e. Now let's integrate from 0 to 3 e with respect to y. 117 pi over 5. Okay, so we've got the right integral. And so, I mean, you know, we could just integrate this. Where did I mess up here? So it's something to do with this technique. So u is equal to y minus 1. You take the derivative, there's no negative or anything, so du is equal to dy. You update the limits. When y is equal to 0, u is equal to minus 1. When y is equal to 3, u is equal to 2. Y is equal to u plus 1. So when you plug that in, you get u plus 1 plus 2. You get u plus 3. Okay, minus, and then if when you come here, this is u squared plus 1 squared. So you have u plus 3 squared, then minus u squared plus 1 squared. Expand this, u squared plus 3u plus 3u plus 9. That's right, minus u to the fourth plus u squared plus u squared plus 1. Well, let's do this. Let's make sure, maybe I'm going crazy with this substitution here. Let's track this down. So if we evaluate this definite integral, so u plus 3 squared minus u squared plus 1 squared times pi. Okay, let's store that as the equation and evaluate this from minus 1 to 2 with respect to u. 117. Okay, so the substitution is right. So there's an error in just the arithmetic. This simplifies to, they take the minus out, and so u to the fourth plus u squared minus 6u minus 8. If we took the minus sign out, we get u to the fourth plus u squared minus 6u minus 8. So we're good up to this point. It's somewhere in here where there's the error. 2 to the fifth, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32, minus 32 over 5. 2 cubed is 8, minus 8 cubed. What the? Why did I put a 24 here? 2 squared is 4, 4 times 3 is 12. All right. And then 16, and then minus, okay, positive 1/5, positive 1/3, positive 3 minus 8. So that's got to be where the error was. Okay. $284 over 15 So 284 plus 67 divided by 15 is 117 over 5. There we go.